Greetings. This presentation documents a 2-year-long full-stack software development effort that turned into sort of a 24/7 epic quest to find out whether AI can help us solve some persistent and chronic design and engineering problems that persist in today's business software realm. I'm Steve King. I'm a conversational designer and an AI researcher. Thanks for joining me on this investigative journey. The testbed for this project was designed as a microcosm of conventional enterprise architectures with a transaction processing reference app that does contract finance and proposal generation. There's a user support chatbot, but beyond that, there's AI embedded in the transaction processing user interface. The main show of this testbed is AI-based business intelligence and data science driven by a conversational input. The foundation of this project is a real working financial app that can be used by service companies who sell maintenance, cleaning, assembly, and repair services to office buildings, manufacturing plants, warehouses, and other commercial facilities. The app helps service managers calculate the work schedule, staffing levels, equipment costs, profit margins, etc., using sound accounting principles. When you look at the user interface, you'll see 6 buttons across the top. The first one, you put in the client details when you're trying to create a proposal for a service contract, the client's building, location, size, layout, the task and hours that you want to provide, all the financial details like cost information, margins, overhead, even the benefits, etc. And then all this gets crunched together into a proposal that you can print out and give to the prospective client. A lot of the magic in this application happens in this analysis tab, where once you build up a history of contract proposals and proposal details, you can slice and dice it with analytics and AI-driven data science. I can start at the proposal process by entering in all new data, or I can select an existing proposal. Let's try this one. And then everything will be filled in for me. I can go to the facility and check the building, its details, the square feet, the type of building it is, and then I can enter my task and hours. This already has a Porter Services task entered. If I wanted to add like pressure washing, I could do that, and plumbing repair. And for each one of these items that gets entered, you enter the hourly rate and you enter the number of hours per day, and those get totaled up. And then the first AI aspect that we can look at is this fly down panel here, where because it keeps a history of every proposal produced, the AI can go back, and when you're trying to configure a task, what's the rate per hour going to be, how many hours you need for this in this specific building, the AI can spit out a range of details that help you configure the contract. So in this case, I'm just going to stick with the one we have, save it, and go look at the financials. This is where I could tweak the equipment cost, supply cost, uniform cost, profit margin, overhead. And in the advanced area, you get into details on benefits and sick leave and Medicare, and even subcontracting, if that's part of the contract. So after the financials look good, then I go to the proposal output page, and I get to see all the proposals that I've done so far. And I see this proposal came in at 50.9K for 24 hours a week, $30 supervisor rate, et cetera, et cetera. Net profit margin is here, 10%. And at this point, if I like it, I can print it out. And here's what a printed proposal looks like with all the key details that the client would want to see. And that's about it for the main proposal flow. Now we can look at the analysis aspects, which is really where a lot of the fun happens. Actually, before we go to analytics, I forgot to mention the second type of AI that's built into this app. In addition to AI embedded in the GUI along with every feature, where it can look into the history and look into the knowledge base and help you. There's also a conventional chat widget here. So if I'm going through the financials and have a question about how overhead is calculated, for instance, the chatbot can go out and look at a knowledge base, and it has a pretty detailed information on financial metrics and sort of business information about proposal generation in general. Here on the Analysis tab, you've got a drop-down menu where you can choose business intelligence done with SQL, where the AI writes SQL, math and stats, where AI does Panda and statistical analysis, and then there's machine learning and time series capabilities. Let's start with SQL Analytics, which is the most generally applicable. I can click on one of these, suggested inputs, and in the background, the AI will look into the OLAP database and do a series of calculations and add up all my contracts in Wisconsin. If I wanted to do a free form question, I could say, show me the top 5 clients in Michigan who have medical buildings by, let's rank by net profit margin rate, and also show net profit in dollars. Let's see what it thinks about that. And this is involving reasoning AI, so it's not instantaneous. It takes its time, it does step-by-step reasoning, and that's where we get the massive accuracy. So there, I know this question pretty well, actually. Those are the actual 5. And of course, if we wanted to chart this, we can say show, let's just say show bar charts. I can add instructions. This is highly conversational. What is the average hourly rate for high dusting in Michigan? Give the answer with 4 decimal places precision. $27.84.91. $27.84.91. Although these 2 numbers come from completely different places, one comes from manually written SQL, the other comes from the model getting a query in the browser interface, they're virtually identical to 4 decimal places. And that's possibly the most simple SQL you could ask the model to write. There's examples with union and CTEs and window functions and subqueries. The model can do some pretty sophisticated stuff. This document is a capture I did of a whole series of queries into the SQL analysis pipeline, and they're virtually all correct, one after another, to 3 digits or more of precision. There is one place in here, I think, where I went wrong because I got confused about company size as employee count versus company size, which is also a slightly different enumerated column. I think it's right here. It got a little bit confused. This is a great example of how AI needs good naming conventions just like humans do. And so when I was a little bit more explicit, I went and looked for the actual field name in the data set, and I used the field name, and there's ways that the software can help you do that automatically. We haven't looked at that yet, but it's a key feature. But anyways, I went and changed my query a bit, and it got it right. So now let's look at the data science part of this, which looks like this. In the math and stats analysis section, we can investigate the data set using Python stats libraries. For instance, I could say, show me 2 histograms for net profit in Michigan and Ohio. And this is going to go out and look at the schema, create a pandas data frame, and then write some Python to answer the question. And there we go. It looks like with some interesting peaks and valleys, particularly in the Michigan data. The math and stats pipeline takes a fair amount of work to set up, but once it's running, it's really a joy to drive. You just talk to it, and it turns out amazing charts and studies. T-tests, chi-square, Mann-Whitney, probability distributions, correlation analysis, Pearson, Spearman, Kendall, variance analysis, regression analysis, confidence intervals. Basically, anything you can do in Python and Pandas, you can now do with simple prompts, which pretty much is the holy grail for business intelligence software that's used by knowledge workers who are not PhD data scientists. I generated all these slides with simple prompts. The results are highly accurate, and the inference is not particularly expensive, even when there's multiple model API calls. Knowledge workers may not understand all the stats lingo that you see here, but they are experts in their domain, and so these visualizations are intuitively meaningful in many cases. For instance, you see IQR, box plot, and area chart here. There's a wealth of information on performance for client accounts, and these same charts we can present with summary language that's geared to any level of skill and sophistication. Here's a set of very correct and wonderfully in-depth answers, violin plots from the Pandas agent pipeline. In addition to SQL analysis and the math and stats we've looked at, the agentic pipeline is also capable of doing supervised and unsupervised machine learning. Here's an example of cluster analysis with scikitlearn. If we paste in a clustering query here with several features that are drawn from the contract database, we'll see the pipeline at work. Depending on whether the query has categorical or numeric data, the pipeline will choose an algorithm like dbScan or k-means or k-prototype, and then it outputs low-dimensional cluster analysis, where you can see the features here on a PCA diagram with normalized scale, and then it will also do a higher dimensional scatter chart. And if we open this, we can see that groups that are closer to the front of this have a higher price and margin. The cluster analysis will pull out interesting insights from the data that aren't necessarily intuitive. Like, for instance, the higher margin contracts seem to be with smaller contract dollar figures, regardless of what size the company is in annual revenue, which is a really interesting potential pattern in customer activity. And then, in addition to the visual aspect of the pipeline output, you can get a tabular view that will round up each cluster and tell you what features like contract price, net profit, annual revenue, and this helps the analysis a lot. And then there's even a deeper level, which looks like this, where the last agent in the pipeline sums up some insights on like what are the clusters that have the most profit possibilities and so forth. Because the machine learning pipeline agents can take advantage of virtually any popular machine learning library and algorithm, the range of outputs and analysis that can be done is quite stunning. And here's the pricing for it. It's always fun to look at that. Last time I checked, I had spent $527. If I refresh this, now it's up to $549. So this was a major breakthrough. The recent GPT OpenAI pricing, what was costing dollars per day with particularly Claude Sonnet pricing, now we can get down to pennies a day, which really makes iteration and training and evaluation and testing worlds easier. Now that we've looked at the application and the analytics and the reporting, let's just glance behind the scenes at how this is built. With AI, by the way, every screen that you looked at, every module you looked at, AI not only is embedded in the application, but it was used to develop this entire code base front to back, top to bottom. So this is an agent-based AI approach where you typically have different models with sort of their own memory, their own context, feeding into each other like an orchestrator agent, typically a schema agent, a code generator agent, and then an output formatter agent. For the SQL module, it looks like this. You've got Python logic, accepting the user query, and then a schema is spit out, and a agent looks at that schema and creates a data catalog that's passed to the next agent that does the actual generation, and then there's another agent that does the formatting. And in some cases, for difficult problems, there can be 3 or 4 or 5 of these agents, and there can be branching logic and retries. We've been pretty successful with that. Out pops the conversational answer, and here it is for the math and stats one, which is pandas and SciPy and Python based, and it's similar pipeline. You've got Parquet files instead of SQL star schema. Schema allows a data frame to be created that's highly relevant to the query at hand, and then we're running stats and math libraries against that data frame, formatting it and kicking it out. Here is a typical flowchart for that same block diagram that we just looked at. Function calls happen at the agent level and then come back to the orchestrator that runs a bunch of functions and then goes to the next agent. To train this thing, it doesn't work out of the box. It takes a lot of iteration to make it work. You sort of have a iterative training process. And by the way, when I say training, I don't mean just training the model. I mean really training the whole system, training the Python code, training the hyperparameters. Everything that's configurable gets touched in this cycle where you start with a query. You have a whole list of queries that you know the answers to. And when it doesn't get the right answer, you do forensics, you refactor, and you retest. So here's a typical set of reference queries and the golden answers in the reference SQL, the SQL that's known to be good. The problem is when you start out with a list of good QA like this, label data, oftentimes a lot of it will be wrong or questionable. And this is typically when you first start out, you just have, the greens are right, the reds are wrong, and the yellows are in between. So at this point, you just go question by question. Here's one where it looked like it was going well. It was hitting all these agents in the pipeline, but it got down here and it said unknown column. It couldn't find this dim building, this dimensional table, extra category. And so at that point, we can go into the logging system where every single call and agent activity is recorded, and you can see what are the prompts that go to the agents. You can see what their inputs and outputs are. And here we can see that there was confusion about an enumerated category. And once I get to the bottom of it, I'll typically write manual SQL to test what the SQL that the model wrote, and then once here you can see that it's looking for a column that doesn't exist. Here's an example of that SQL that gets written, and here's an example of where you can see all the tables and fields in enumeration in the analytical layer. And in this case, once I have a fairly good idea of what went wrong, I will get Claude Code involved in, and Claude will do some forensics of its own and typically will agree on what the problem is, although there's many times when Claude does go off in the weeds and we have to beat him over the head until he sees reason. And then here's where the prompt's getting updated for that particular failure. And once this prompt is updated and it gets run again, then it looks like it ran correctly. No matter how good the models and the code and the hyperparameter settings are, if the schema is terrible and the names are confusing, everyone's going to be confused. The humans the models, the Python, you name it. So there's a bunch of things that can be done to fix this. None of them are particularly easy or pleasant, but through some combination of them, the naming and the schemas can be cleaned up. Like refactor the namespace. This is always the one that the AI engineers love, because if you can refactor the schema before the model sees it and make the names clear and concise and unique, there's a lot less ugly code that has to be written in the back to try and map sensible names to the bad names. And here's where the mapping takes place. There's always some of this. And then also in the front end, there's wonderful things that we can do to help users, help the models disambiguate the namespace language. It's also always good to have conversational loops so the human and the bot can go back and forth and work it out in real time at query time. And then it's always good if you've got a massive data domain with hundreds or thousands of tables and columns, break it up in subdomains and then let the user through the GUI focus in on a subdomain so that the poor model isn't looking at thousands of columns with similar names. And so really what we're talking about here ideally, why do you think they call it a language model? You know, we're talking about language here. And so ideally what we need to move to is shared namespace where all of these components of the full stack participate as much as possible in a shared namespace. And that includes back-end, front-end, the user, the language model, and any fine-tuning done on the language model. And really, ultimately, this becomes an issue of organizational learning and organizational linguistics. So why did it take 2 years to do what should have taken 2 weeks or 2 months? 2 years ago, none of this stuff was mature. There wasn't enough model inference power. The latest generation of reasoning models has really helped. The AI libraries and framework weren't in any shape worthy of trying for production code 2 years ago, and they still aren't for the most part. The content retrieval, like so-called RAG, really problematic. And just how to code around the AI and build the scaffolding that the AI needs to have these pipelines work. This is something that's taken a while to master. And then there's the token economics that the prices have come down for inference. A lot of this boils down to programming versus prompting. You'll see some frameworks that really focus on programming and they want to minimize how you write prompts and create context. And then you'll see others that are all about the prompting and minimize the programming. I found that it's really great if you can balance these two. Write some great code and great procedural functional logic, but then also agonize over the prompting, because ultimately in the long run, we're shifting our business logic to prompting, and the better we get at it, the faster things will move. I found that there were many, many cases working with Claude Code to pair program this AI platform that Claude was completely out in the weeds. It was what the AI engineers call out of distribution. There's tons of training for language models in Python and GitHub and JavaScript and React, but there is not nearly as much in creating agentic pipelines. And so many, many times I saw Claude fall back to knowledge that just predated my project. And I had to beg Claude over and over again to look at the new stuff. I would give it source code. I would give it documentation for the new approach to prompting along with programming. And the touching thing was sort of at the end, even though in many ways it didn't seem to understand, ironically, how AI agentic programming works, it wrote a README where it said we've achieved the perfect balance of LLM prompting and traditional programming. We've created a system both powerful, maintainable, flexible, reliable. We reduced a lot of code. This is where I had it rip out explicit business rules that it wrote in Python and replace it with just a little bit of prompting. So no thanks to you, Claude, or only partial thanks to you. It did work out to be a great project. During the entire 2-year course of this project, there was, of course, a huge amount of hype going on about the potential for AI and billions of dollars being shoved into the field. But at the same time, there was an increasing drumbeat on project failures and lack of consistency, hallucinations, poor user experiences. And here's a couple examples that occurred in very expensive projects for top law firms, Lexis and Thomson Reuters, There's a similar thing, several similar things in medical projects where, just the accuracy was astoundingly bad when it came to medical diagnostic reasoning. Same thing in productivity products, where recently Microsoft launched AI in Excel with the caveat, don't use it for things that require accuracy, which is pretty hilarious considering that's the whole point of Excel. And in general, as we were working day and night to get AI to answer questions about structured data sets, there was from a lot of engineers the belief that you shouldn't let AI write SQL. And in spite of all these failures, we kept trying. And here's a very recent report from MIT that 95% of pilots aren't doing well, aren't performing like they should. The interesting thing is that we found that only about 5% of the tools and libraries and methods that we tried work. So this actually makes sense. There's a very small club of 5% of AI engineers and technology tools that work, and a huge amount of snake oil out there. Thanks for listening.